Hello everyone. The topic is on green chemistry. So chemistry has played a vital role in improve our life, but all these developments are responsible for various environmental problems. The most important effect is due to release of hazardous byproducts of chemical industries and the release of non-biodegradable in the air, land and water bodies. So some of the environmental problems are acid rain. It is caused by the oxides of nitrogen and sulfur. Then global warming. It is due to the carbon dioxide, methane, nitrous oxide and chlorofluorocarbons. So these pollutants alter the climate. And then photochemical smog. And these environmental problems result some deadly diseases. For example, Minamata disease. It is the case of mercury poison. In 1950s, more than 50 people died and a number of people were affected in Minamata, a seacoast village in Japan. So the reason was attributed to eating of fish contaminated with mercury. So it was found that the waters of Minamata Bay were polluted for more than 30 years by dumping off an estimated 27 tons of mercury by Chisco Chemical Company. So this company was using mercury chloride as a catalyst for the production of acetaldehyde. And another case, Ita disease. It is due to the cadmium pollution. So an unusual disease called Ita disease was reported around 1912. It is due to cadmium pollution in Jinsu River Basin in Toyama in Japan. So the victims, mostly women, suffered with acute pain in the entire body, and more severe cases suffered broken bones when trying to move of their own. So it is in this context that green chemistry plays a vital role in keeping the environment clean. So what is green chemistry? So green chemistry, it is defined as a environmentally friendly chemical synthesis. So harmless synthesis and a smart chemistry and also efficient synthesis. So green chemistry is defined as environmentally benign chemical synthesis. This was achieved by replacing an organic solvent with water. Usually we are using organic solvent, but in green chemistry, instead of using organic solvent, it will be replaced by water wherever it possible. The reactions were conducted in solid state without the use of solvents. Green synthesis were developed for existing products by using starting material that use biomass rather than petrochemicals. That is, the starting material we use the most of from the biomass instead of using petrochemicals. For example, adipic acid preparation. Adipic acid usually prepared from benzene. So in green chemistry way, we can prepare it from glucose. So it is the biomass. Instead of petrochemical, it is prepared from biomass. About principles of green chemistry. The term green chemistry was coined by Professor Paul T. Anastas, who is known as the father of green chemistry. Professor Paul T. Anastas and Professor John C. Warner have postulated 12 principles of green chemistry. These principles are given in detail. So we will discuss in detail the 12 principles. The first principle is prevention of waste. So it is better to prevent waste than to treat or clean up waste after it is formed. Second principle is atom economy. They are talking about on atom economy. What is atom economy? The amount of starting materials incorporated into the desired final product. So the synthetic method should be designed to maximize the incorporation of all materials used in the process into the final product. So all materials used in the process into the final product, that is atom economy. Third one is non-toxic product synthesis. Synthetic methodology should be designed to use and generate substances that should be non-toxic. The fourth one is designing safer chemicals. Fifth principle is use of safer solvents and auxiliaries. The sixth one is design for energy efficiency. Minimum energy requirement. Energy requirements should be recognized for their environmental and economic impacts and should be minimized. Synthetic methods should be conducted at ambient temperature and pressure. The seventh point is use of raw material of feedstock should be renewable. So we discussed about the preparation of adipic acid. About 2 billion kilograms of adipic acid are required each year for making nylon, polyurethane, lubricants and plasticizers. The usual standard procedure of making adipic acid uses benzene from petrochemicals, which can cause cancer. The benzene is non-renewable. In a newly developed process, it is aided by biocatalysis. The simple sugar glucose can be used as the starting material instead of benzene. The starting material, sugar glucose, is a safe substance to make adipic acid. The use of large quantities of a harmful chemical can be avoided. So this glucose is a renewable energy source. So this seventh point implies use of raw material of feedstock, that is the reactant raw material of feedstock, should be renewable. Eighth principle is reduce derivatives, that is blocking groups, protection, deprotection, temporary modification of chemical and physical process should be avoided in the synthesis, that is reduce derivatives. The ninth point is use of catalyst. So we need to choose catalyst to increase selectivity and minimize waste. 10th point is design for biodegradable products. The 11th principle is strengthening analytical methodologies. That is, we need to monitor the chemical reactions in real time and control prior to the formation of hazardous substance. 12th principle is avoid chemical accidents. Substance and the form of substance used in a chemical process should be chosen so as to minimize the potential for chemical accidents, including releases, explosions, and fires. I recall these 12 principles. First one is prevention of waste. Second principle is atom economy. Third one is non-toxic product synthesis. Fourth one is designing safer chemicals. Fifth one is use of safer solvents and avoid separation techniques, that is auxiliaries. Sixth point is design for energy efficiency, that is minimum energy requirement. Seventh point is use of raw material of feedstock should be renewable. Eighth one is reduce derivatives. Ninth one is use catalysts to speed up the reaction and increase selectivity, minimize waste. 10th one is design for biodegradable products. So the synthetic method should be designed to get biodegradable products. 11th point is strengthening analytical methodologies. We have to monitor the chemical reactions and avoid hazardous substances, control prior to the formation of hazardous substances. 12th point is avoid chemical accidents. Let's see the concept of atom economy. The concept of atom economy was developed by Barry Drost of Stanford University. This concept considers the amount of starting materials incorporated into the desired final product. The concept of atom economy, along with the ideas of selectivity and yield, greener, more efficient synthesis, can be developed. According to B.M. Drost, we must find out how many atoms that are found in the reactants are incorporated into the final product. From this we can find out the formation of waste byproduct. Percentage atom economy was calculated as given below. The percentage atom economy, which is equal to formula weight of atom utilized divided by formula weight of all the reactants used in its reaction into 100. So using this formula, we can identify whether the reactant is completely utilized into products or not. Let us see the example. Claisen rearrangement reaction. Here, allyl phenyl ether on heating at 200 degrees centigrade to give orthoallyl phenol. Just notice the table. Here the formula, reagent formula is, that is allyl phenyl ether formula is C9H10O. And formula weight is 134.173 gram per moles. Utilized formula, that is a product, orthoallyl phenol formula, C9H10O. And the formula weight is, that is product weight is also 134.173. So the percentage atom economy is calculated 134.173 divided by 134.173 into 100. In the above rearrangement reaction, it is an 100% atom economical reactions. All the reactants incorporated into the final products, that is all allyl phenyl ether is incorporated into orthoallyl phenol. Next example is elimination reactions. In Hoffman elimination, trimethyl propyl ammonium hydroxide gives propene as a main product and trimethyl amine as a byproduct. Here reagent formula is C6H17NO. Formula weight is 119.205. Utilized formula, that is the product formula, propene formula, it is C3H6. the molecular weight of propene is 42.080. Unutilized formula, that is the byproduct formula, C3H11NO. So we are going to calculate percentage atom economy, which is equal to 42.080 divided by 119.205 into 100, which is equal to 35.30%. So this reaction is not very atom economical.